Welcome to this video. My name is Chris Noring. I'm going to talk about some features in the ES6 and the ES7 that I really think you should be using. The first feature I want you to care about is something called the spread syntax. Now looking here, we have two different arrays. One is called first half, whereas the other one is called second half. Now first half just looks like a plain array. We got two different items, 1 and 2. The other one is called second half. Now if we scroll a bit, we see that second half consists of the elements 3 and 4, but it also consists of first half somehow. We have this ... syntax. So what does ... mean? Well, it simply means that we're comma separating first half, which means that we effectively get an array that looks like 3, 4, 1, 2. So that's actually all you need to know about the spread syntax and its ability. But I would like to show you what the consequence is of not using this syntax. So that's up next. Now, so in this case, we have first half as our normal array with the elements 1 and 2, and we got second half, which contains 3 and 4. Now looking at the syntax here, we can see the following. We can see that we need to iterate through first half to just iterate through all the different elements, and then we need to push those into second half. This will effectively achieve the very same thing as we did with the spread syntax, but it's less elegant and it requires us to use a for loop. Okay, spread syntax is not only about arrays, we can definitely use those on objects as well. So here at the top we got an object that we call hero. It consists of the properties name and real name. Secondly here, if we scroll a bit, we got another set of objects. We got an object that we called hero with sword. Now this object bases its properties partly on that of hero. And we can see that by us using the spread syntax on hero, which effectively means that we are copying in those values from hero and use that to base our hero with sword object. Also we add the property weapon on it. So the end result is us having a merged object that consists of the former hero object, but also whatever hero with sword comes with. So the end result is 3 properties: name, real name, and weapon. So what's the alternative to not using the spread syntax on object? I mean, I was fine using object keys, right? Well, no, not really, right? I mean, if you look at this, you see that we use object keys on our hero object, and thereby getting all the properties that it consists of. And then we use a for loop to go through the object and understand what keys do you have, and simply assign those to the empty object literal. And of course, the end result is still this, but we need to use this for loop to achieve the very same thing. So I hope I convinced you by now, spread syntax is the way to go, regardless of whether you're dealing with arrays or objects. Alright then, let's have a different look on things by introducing something called the rest syntax. Now the rest syntax looks very much the same as the spread syntax that we just talked about. It still uses this ... syntax, but it works differently. At the top here we can see the function add that takes 3 parameters in: first, second, and the one called remaining, but we are adding this rest syntax ... to it. Looking at the function body, we can see that we concatenate first and second to produce a result. Looking here at line 5, we can see that we call add with 2 different parameters, 1 and 2, which means they are going to be stored in first and second according to the function definition, which also means that we are not actually using the remaining parameter here. Let's talk about the point of using this. The point of using this is in how we call add function on line 7. Here we can see that we got 4 different input parameters, 1, 2, 3, and 4. And the idea is for 1 and 2 to be stored under first and second, and 3 and 4 to be collected in an array in the one called remaining. So remaining has the ... syntax has the ability to take all of those extra parameters and collect those into an array. Here we can see that we are implementing the add function a bit differently. Now this time around we still have the ... remaining as the 3rd parameter, but we are doing things differently. We are using a reduce call on the remaining parameter, and thereby we are taking all of those extra parameters that are not stored in first or second, and we make sure that those turn into an array, and we make sure that that array is being reduced and added to first and second. So thereby we could either call add with 1, 2, 3 or 4, 5, 6. It doesn't really matter. The point is the reduce is going to ensure that we take care of 3, 4, 5, 6 in the same way as we would call it with 3 and 4. Okay then, let's talk about something called string interpolation. So what is it? Well, let's first talk about the fact that we need it. We can see that by us defining this class called product. Inside the product we got a method called getDescription. We are concatenating 3 different strings to form this full description string. It's not very nice to look at all. So what is actually the alternative to doing it this way? Well, here we have an alternate implementation of getDescription. So what we're doing is to use something called backticks to define a multi-line string. Multi-line isn't everything, but we can also interpolate, and we see that we do that through the $curly brace. So we're able to mix and match between parameters and the full string, and the readability increases a lot. Okay then, let's talk about something called shorthand properties. First off, let's not use it. Let's try to just understand the scenario here. So we have the factory method createChord, which creates an object for us with the properties x and y. What we can see is that the input parameters x and y are being assigned to properties on this object literal called x and y. Now, why is this bad? Well, if I don't need to type all of that, why should I, right? I mean, I want to write as little as possible while still make it readable, and yeah, don't waste characters when you don't have to. So let's have a look at what is better, which is shorthand properties. Now, in this alternate implementation, as you can see, we have removed the colon, so we're no longer typing x:x or y:y because we don't have to. And the reason for that is that the properties on the object literal actually matches the name of the input parameters. And that's what shorthand properties is. When you have a name match like so, you don't actually need to write everything out. That's the great part. We are writing less, it's still readable, it's great. Use this feature. Alright then, let's look at a feature called method properties. Before we do so, let's try to understand what the code looks like if we don't use it. So here we're defining this object literal math, and math has 3 different properties on it: add, sub, and multiply. Now each of those properties have a syntax that kind of looks like this. We have the name of the property, which is for example add, then we have a colon, and then we have the function keyword, and then the rest of the function definition comes. It's the same thing for add, sub, and multiply. We can actually improve this with the same level of readability but just less characters. So let's have a look at using these method properties. Here we see the exact same object literal, but what we've done is to remove the colon, we have removed the function keyword, and we have just made less characters. We have the same level of readability, so instead of add colon function, we write add parentheses straight away. Same thing with sub, and same thing with multiply. This is great, right? Increased readability and less characters. Alright then, we're going to look at something called object destructuring. So first off, let's try to understand what the problem is. So here we have this method handle. Now handle has a request object, or rec, that it takes as an input param. In that rec object exists a few interesting properties that we want to keep on using. So we want to dig out name, description, and URL. But here's the problem. They exist on different depths in our object. So for example, name exists under rec body, whereas description also exists under rec body, but the URL exists directly under rec. So as you can see, they are on different levels, and we also need to define 3 different variables to actually dig out these values. Because main reason for doing this in the first place is to make our code easy to read, because nobody wants to read the full rec body name repeated X number of times throughout your code. So what is better? Destructuring. Looking at our handle method here, we have defined it differently. So this time around, we are actually using object destructuring. We can see that we do so by actually the const curly braces. So const curly braces is the same thing as saying I want to destroy or pick apart this request object, and I want to dig out those variables that I care about. So what it's saying is that on the first level, you got this body property. Under body, we have name and description that we actually want, and we know that URL is on that first level, at the same level as body. So what we are doing here is to saving ourselves to type the fact that we need name, description, and URL, so we don't have to define those variables. That is being done for us as we dig them out with this destructuring statement. Alright then, let's talk about something called array destructuring. What this means is that we kind of pick apart our array and we try to select the elements that we need with a very elegant syntax. First off, let's not use it and try to understand how much more we need to type. So here we have array. It contains X number of elements. Const A is trying to dig out the first element, whereas const C here is trying to dig out the third element. Nothing really wrong with that, right? But imagine that we had this elegant syntax at our disposal instead. What then? Well, let's have a look. So down here we are using our elegant syntax by using destructuring on the array. So instead of using these curly braces on the array, we're using these square brackets instead. Now, so the A matches the first element in the position. As for the second element, we don't actually give it a name, but we just ignore it. And that's what this empty space means. Then we have C, which is our third element. And lastly, we collect all of those remaining items in the array. You see how elegant that is? Let's talk about something called parameter matching. Now, to understand what that is, let's first establish what the problem is. So here we got a function called doSomething, and it has this input parameter config. Now config is being used on line 2, 3, and 4, and we type config.a, config.b, config.c. I don't know about you, but I'm awfully tired of seeing this config something. I wish I could take it away. And that's exactly what I can do with this elegant syntax. So let's have a look at what better looks like. Here we have our function doSomething. In this case, we have taken our config object and just made it cease to exist, or rather we have destructured it. So here we are digging out A, B, and C. And our if clauses now on line 21, 22, and 23 becomes awfully nice to look at. No config.something, but just A, B, and C. Use this one.